So I wanted to give a short talk, we'll see, about Bayes' theorem and Bayes' rule, because I keep having to explain it to people and people keep not wanting to understand. Okay, Bayes' rule says posterior odds equal prior odds times likelihood ratio. And it's a simple rule which one uses and should use to update beliefs, relative beliefs concerning two competing hypotheses, given new information. You get new information and you should alter your opinion about a question of interest. And one can write it as posterior odds equal prior odds times likelihood ratio. But then we have to explain what likelihood ratio means. It's the strength of the evidence, the relative strength of the evidence for the two competing hypotheses. And there's some more details there about who invented it. And the picture of myself keeps stopping. I don't know why. Let me try again. Let's continue. I would say that this is a quantification of a very well-known aphorism that all extraordinary claims require extraordinary evidence. And the thing is that in a serial killer nurse case, serial killers are rare, serial killer nurses are pretty rare too. So if you want to convict a nurse of serial murder of patients in their care, you're going to need strong evidence. I would say this is completely obvious and uncontroversial. It's an unusual crime, so it's going to need strong evidence to prove it. Now, actually, about that question, forensic psychologists and criminologists will argue that the profession attracts psychopaths and sociopaths because nurses working on a ward where people die do have opportunity and means to kill and hardly be noticed. Opportunity and means. And okay, so those are issues which need to be taken into account, whether or not we believe that and how much we believe that. But let's press on. I want to get to Bayes' theorem. Now, I'm going to have a little rant here of 4 slides of what Wikipedia says Bayes' theorem is. It states, first of all, the website, the article on Bayes' theorem says Bayes' theorem is stated mathematically as the following equation. Well, that's not actually the equation you have to use in practice. And I would also say it can be stated mathematically as this equation, but there are possibly other equations which is much better to use as the mathematical version of the theorem. But anyway, it's a theorem about probabilities and conditional probabilities, and notice it says probability of A given B is probability of B given A times probability of A, and A is the event, is one of the two competing events which you want to compare, and B is the evidence. So this is the probability of event of hypothesis A given evidence B. But now you need to know the probability of A in advance, before getting the evidence, the prior probability. You need the probability of the evidence given the hypothesis. So what is the probability of the evidence given that Lucy Letby is the killer? But you also need to know the probability of the evidence, P of B. But what is it? Well, you'll have to read a long way through the article to find out how you can compute it, and it's implicitly in this formula here, which turns up a lot later, where we also get not A, which is if A is that Lucy is guilty, then not A is that Lucy is innocent. So we need more. We need the probability of the evidence given A is not guilty, as well as the probability of the evidence given A is guilty. So this is basically a lie. I mean, it's just it's mathematical and it's confusing. It's mystification. It's not what you actually use. It's not what you actually use in practice, and it doesn't help you. It's part of the proof. Well, of course, the proof is a triviality, and here's the proof. The proof is a couple of just two lines basically. I mean, you write down a definition, you repeat the definition, and then you with different terms filled in. So it's stating the definition 2 times, and then you could say dividing one equation by the other and rearranging. That's all it is. So it's a triviality. It's a triviality, and of course it was known before. It was known before Thomas Bayes discovered it. Surely people had used it many times before, because it is so trivial it's not even worth calling a theorem. But anyway, it is a useful thing to know. But it's a useful thing to know when you state it in a convenient way to use. There's a little bit more of the Wikipedia stuff. And after a long time, you get to see it in odds form, which I think is the way to state it. But first of all, we have to introduce more notation, an O and a lambda, and it looks very complicated, and it's just getting more and more complicated instead of more and more simple. Now, this is how I think the theorem should have been stated right away at the top, and how it would be, and how it is easiest to use. Start off by saying Bayes' theorem says the ratio of the probabilities of A prime and A, so that could be Lucy is innocent to Lucy is guilty, given certain evidence, is the ratio of the probabilities of the same 2 events, the same 2 hypotheses, guilty to innocent, before you saw the evidence. So without seeing any evidence. And you go from the prior ratio of probabilities to the posterior ratio of probabilities. I should say the ratio of posterior probabilities. You go from the ratio of prior probabilities that we call odds, the odds on A prime versus A, to the odds on A prime versus A given B. We've got evidence B, it changes our prior odds to our posterior odds. And how does it change it? We have to multiply by the ratio of the probabilities of the evidence B under the 2 competing hypotheses. Probability of evidence given guilt, probability of evidence given innocent. Or depending which way around A and A prime are, you can do them both ways. And now I saw this on Reddit recently in a discussion on Reddit Science Lucy Letby, not the Reddit Lucy Letbit, not the Reddit just called r/Lucy Letby, where you're only allowed to write on that Reddit if you believe Lucy Letby is guilty and you completely trust UK justice. Otherwise, you get chucked out. In the Reddit r/Science Lucy Letby, you can have either this point of view, and and both points of view are discussed. Anyway, somebody wrote this, and he has got events A, Lucy Letby is guilty, B, evidence. Sorry, it's a fictitious example. A new nurse, Letty Lusaby. Letty Lusaby is responsible for deaths. B, Letty Lusaby was present at a large majority of suspicious events. So and of course there's also another event, he calls it an event, I would call it a hypothesis, and it's not Letty Lusaby is not responsible. And he starts, or she, I forget, giving us 3 probabilities. Probability of guilt before we see any evidence. He makes it 1 in 1,000. Probability that if Letty Lusaby is guilty, that she will be present at a large majority of suspicious events, and he takes that probability to be close to 1. But he also puts in another probability into the calculation, and it's the probability that Letty Lusaby, the probability that our nurse Letty would be present at a large majority of suspicious events, given that she's innocent, not guilty. And he takes that to be 1 in 100. Then he uses Bayes' theorem, and he's clearly copied it from Wikipedia, and he has to do this calculation. Okay, so he needs to pull out his pocket calculator, and he has to type in all those numbers, and he has to get it right, and I can assure you it is right. He comes, he's not finished yet, because this is only the P of B, which is needed here. Right, you have to calculate this probability, and it's given by this awful formula, and you fill in the numbers, and then you substitute it there, and then you calculate. Now only you can calculate this, and you get this, 0.09. Now, he says, is that surprising or not? But anyway, the posterior probability is 90%, only 90%, about 90%. Anyway, now, I think this is the wrong way to do the calculation. It's misleading. It's irresponsible. It's an invitation to make mistakes. And this is how it should have been done. A is that Letty is guilty, not A, which I'm going to write as A prime, is Letty is innocent. The prior probability of guilt was taken to be 1 in 1,000. That means that the prior odds on guilt are 1 to 999 against guilt, right, in favor of innocence. Before seeing any data, it's 999 to 1 that Letty Lusaby is innocent. And I'm going to approximate that with 1,000 to 1. And I do assure you, changing 999 to 1,000 hardly changes the final result. Right? It's a 1 pro mil approximation, so it's not important. And it makes the numbers easier. So 1,000 to 1 initially that Letty Lusaby is innocent. Then we have the evidence. She was present at many suspicious events. This probability is almost certain if she's guilty. It has a probability of 1 in 100 if she's innocent. We must look at the ratio of these two probabilities. 1 divided by 0.01. That is 100 multiply both of those numbers by 100, and you get 100 divided by 1, 100 to 1. So the strength of the evidence for guilt versus innocence is 100 to 1. Okay, it's definitely strong evidence of guilt, but is it strong enough? Answer, no. Bayes' theorem says that we get the posterior odds on guilt versus innocence by multiplying this ratio, 1 to 1,000. You could say 1 divided by 1,000. I say 1 to 1,000. By this ratio, 100 to 1. You multiply the 1 by the 100 and the 1,000 by 1, and you get 100 to 1,000. The ratio is now 100 to 1,000. Divide 100 and 1,000 both by 100. You're allowed to do that. 1 to 10. So the posterior probability of guilt, you have to add 1 and 10. It's 1 out of 11. It's 1 out of 11 chances. The odds are 1 to 10 against guilt. The chances are 1 in 11. And 1 divided by 11 is 0.09, and then some more. So I hope this shows that Bayes' theorem calculations are very simple. Now, the problem, of course, is where do those numbers come from? We need this number, the initial probability of guilt. We need the probability of the evidence given guilt. We need probability of evidence given not guilt. That's very, very important. We need the probability of seeing that evidence given she's not guilty. We need both those two. And their ratio tells us how strong that evidence is for distinguishing between guilty and not guilty. And, okay. So the numbers have to be found. They have to be argued. You have to argue what numbers you're going to take. And you're probably going to need data from the past in order to get some idea about this. Like 1 in a million people are serial murderers. Maybe a bit more than 1 in a million nurses are serial murderers. That can be doubted. That is something we can discuss. We have lots of evidence. We have all kinds of evidence. We have a mountain of circumstantial evidence, which can be interpreted in many, many ways. Can be seen as it sort of agrees with guilt if you put the right story on it. But if you put a different story on it, it agrees with innocence. So I would say the circumstantial evidence is pretty much a waste of time. It's ballast, it's noise. There is some real evidence. There was a spike in deaths. Lucy was often there at events which were called suspicious. We have to find out why they were called suspicious, how and when and by whom, and so on and so forth. And we need to know all kinds of things. A nice thing about Bayes' theorem is that we can apply this rule, updating prior odds to get posterior odds. One can apply it repeatedly. One can take one, not in one go, looking at all the evidence. An ordinary person can't do that. Well, I mean, maybe an ordinary person does look at all the evidence and then immediately update prior odds to posterior odds in their minds. But okay, you might be mistaken. If you want to argue why you are at a certain point certain of innocence or certain of guilt, you better have a decent argument for it. And I would recommend separating the evidence into lumps, into blocks, and starting with something sensible, and then taking something which is pretty incontrovertible. For instance, I like to start with my argument that if police are investigating a nurse because of a bunch of a spike in deaths at a hospital in the NHS on a particular unit where the nurse worked, then I have reasons to argue that initially I would still 50-1 believe the nurse is innocent. But maybe one should start a little bit earlier and say a nurse is, the police is called in. And we don't know yet if they're going to investigate a nurse, but we know there's been a spike in death. Police are called in, and I'm interested in the question: was this just another NHS catastrophe, as there is one every year basically on a neonatal unit? So I start with a neonatal unit in the NHS. Police are called in for a spike in deaths. And the question is, was it a typical NHS catastrophe or was it a killer nurse? And which is clearly a less typical event. It is, of course, also an NHS catastrophe, but it doesn't happen so often. I think it happens less than 50 times as often. I think I'm being very sort of, giving the chance of guilt a very good start by saying, well, let's take it 50-1 for innocence. Well, for no serial killing, right? For no serial killing. Then let's bring in a new block of evidence, then a new block of evidence, then a new block. I do it in 4 or 5 steps. I'm, as we say in Dutch, sucking numbers out of my thumb. I'm appraising, I'm quantifying my degree of belief in various things. What is my probability of this given that? How much would I, how at what odds would I, and what would I bet? How would I bet on this versus this given that? These are the things I ask myself. What would a sane, rational, well-informed person think is the probability of A given B for a whole sequence of choices of A and B? I do it with just a small sequence. Okay, so I think this is enough. It's a little lesson. I hope it will help somebody out there. and possibly lead to further discussion is also great. Right, now I have to stop. Oh, I stopped my clock, but not my recording. No, I stopped the recording.